Okay, Algebra 1 students, in this video today we will be looking at solving quadratic equations, okay? Plus, we're going to throw in some other small odds and ends along the way, okay? Please copy this heading in your notes if you would. Solving quadratic equations by using the square root method. Please copy that in your notes. Solving quadratic equations by using the square root method. Lesson 9.1. And be sure and copy today's date at any time through this video. Throughout this video, if I go too fast, please pause the video. Alright? And here we go. Before we get into the meat of the lesson, which is solving quadratic equations, let's look at a couple of small things that need to be learned or reviewed, okay? So, here we go. I would encourage you to take some really good notes on this. Now, first of all, actually I just said I would encourage you to take some notes, but I don't think you need to take notes on this first part. You can if you want to, it's up to you, but I want to quickly review what it means when I square something and what it means when I take the square root of something. Here I am squaring the 5. Here I am taking, my pen's not working very well today, the square root of 25, okay? Now 5 times 5 is 25. And we should know by now, students, that the square root of 25, very sorry guys, square root of 25 is 5. Why? Because 5 times 5 equals 25. So the square root of 25 is 5. Okay? So we should know by now when you're in high school or middle school, depending when you're taking Algebra 1, but you should know by now how to find the square root of a number. For example, the square root of 100. Some students would say it's 50, and that's not correct, because 50 times 50 is not 100. The square root of 100 is 10, because 10 times 10 is 100. So the square root of 4 would be 2. The square root of 9 would be 3. The square root of 16 would be 4, and so on and so forth. Do you understand? Now what if I gave you a number that's not a perfect square? By the way, when I say perfect square, that means you can take the square root of it and get out a whole number. Like the square root of 49 is exactly 7. However, the square root of 48 would be 6 point something, probably 6.9, and some more decimal numbers, okay? This is not a perfect square. 49 is a perfect square, okay? So, understand that when I say perfect square, I mean numbers like 2 times 2, 3 times 3 is 9, 16, 25, 36, 49, 64, etc. Those are called perfect squares, okay? Now, take some good notes on this. Here we go. First of all, I need to show you something. Please copy this in your notes. If I asked you to find the square root of 64, you would say the answer is 8, right? And if I said why, please take notes on this. Copy all this down, okay? Please take notes on this. And if I asked you why, you would say because 8 times 8 equals what? 64, which is the number we have here. But I would like to say to you, we have another answer to this, and that's negative 8, right? And if you asked me why, I would say negative 8 times negative 8 equals what? 64. So really, every square root has two answers, a positive and a negative. Does that make sense? It should. Alright? So, every square root technically has two answers. Is that clear? Understand that. However, in mathematics, when you're given a problem like this, it is understood to just put the positive answer. If you're given a problem like this, write all this down, please guys, take notes on this. If you're given a problem like this, then your answer would be negative 8. You bring down the negative and you put it here. If I gave you a problem like this, positive, negative, square root of 64, then your answer would be both positive and negative 8. Do you understand? So even though the square root of of 64 technically has how many answers? 2 answers. You only have to put one answer, unless of course I have positive negative here, then you would put positive negative with your answer. Do you understand? Okay? It's very important that you understand that. So, if you're given this problem, your answer is positive 8. If you're given this problem, the answer is negative 8. And if you're given this problem, your answer is positive negative 8. Or for any square root, that's true. Even if it's a decimal. Okay? Now, let's continue taking some good notes, please. I hope you're understanding this. Now, if I have this, I guess I'll continue to use 64 since that's what I've used so far. And if I had this, do you students see the difference between these two problems? I hope that you do. One has the negative sign outside the radical. Okay? And this problem here has the negative sign inside the radical. Do you see the difference? And by the way, while we're working on this, why don't we take some notes real quick? Well, I'll tell you what, I'll get to that next. Let me finish this first. So, do you see the difference between these two problems? Now, I already showed you the answer to this is negative 8. But the answer to this is no solution. Write that down, and then I will explain why. The square root of negative 64 is no solution. Okay, now, let me explain why. If you said, Mr. Earhart, you're wrong, the answer to this is negative 8, I would say, really? Okay, so you're claiming the answer is negative 8, right? Okay, then that means negative 8 times negative 8 should give you this number right here. And negative 8 times negative 8 is a positive 64, not a negative 64. So negative 8 doesn't work. Okay, the answer is positive 8. Okay, let's see if it is. Positive 8 times positive 8 is positive 64. Still not a negative 64. Do you see what I'm saying, guys? It's impossible to multiply two identically like numbers together and get out a negative. It's impossible. It can't be done. Okay? And that's why you can never take the square root of a negative number. Now here it's okay because you're not taking the square root of a negative number. You're taking the square root of a positive number, which is 8, and then bring the negative sign down. That's a lot different than taking the square root of actually a negative number. So you cannot take the square root of a negative number. It's no solution. Now, when you get to higher level math, you will learn this. Do not take notes on this, just watch. You will learn that something like this, the square root of negative 25, actually equals the square root of 25i, which stands for an imaginary number, and the square root of 25 is 5, so the square root of negative 25 is 5i. You will also learn later that the square root of negative 1 always equals I. Okay? And thus I squared equals negative 1, but that's not for today. That's future down the road in Algebra 2. Okay? So, let's review for a second. Make sure you know how to find the square root of a number. Secondly, understand that some square roots will have a positive sign here, some square roots will have a negative sign here, and some will have both. Understand that. Understand you cannot take the square root of a negative number. The square root of a negative number is no solution. Now, I'd like you to take some more notes. Copy this down, please. If I have something like the square root of 50, okay, this box like this somewhat similar division looking box is called a radical. I want you to write that in your notes so you use the proper terminology. It is called a radical. The number on the inside is called the radicand. You need to know that. inside is called a radicand. Please copy that in your notes. Now moving on. I want to talk to you about something called radical form and decimal form. If I gave you a problem like I just had, square root of 50, and I said, leave that in radical form, that means you leave your answer like this. Here's your radical. And you leave it like this. Got it? That's your answer. Boom. You're finished. Done. That's called radical form. Why don't you write that in your notes? RADICAL, radical form. That's really radical, dude, isn't it? Just kidding. Alright, radical form. Now, if I asked you to write your answer in decimal form, then you would take your calculator and you would type into your calculator the square root of 50, which I'm doing right now with my calculator, and I'm getting out 7.071067812. Of course, you do not have to write that entire answer. You could round to 1 or 2 or 3 decimal places or wherever the instructions tell you to round, okay? But my point is understand when I ask you to write your answer in radical form, leave the radical there. If I ask you to write it in decimal form, leave it like this. Okay, now, one other thing. If I gave you a problem like this, obviously, you would just solve that and put 9. We're not going to leave it in radical form. So if it's a perfect square, we know the answer is obviously 9, okay? That just makes sense. The square root of 81 is 9. However, if I had the square root of 87, then you've got a choice to make. You're either going to leave your answer like it is, which is radical form, or you're going to type into your calculator and get out a decimal answer. Got it? Okay. If you missed any of this, back it up and watch it again. Now, let's get into quadratic equations. First, let me give you an example of what a quadratic equation looks like, okay? This is a very standard quadratic equation. X squared minus 6x equals 10. There. Now, I'd like you to copy that in your notes, please. I'm going to compare that to a linear equation. There's a linear equation. Please copy that in your notes. What's the difference, Mr. Arrowhead? How can you tell the difference? Actually, quite easily. Are you ready? A quadratic equation, the highest exponent of a variable will be a 2. I would write that sentence in your notes. That's up to you. The highest exponent of a variable will be a 2. So here's a variable. What's my power? 2. Here's my variable. What's my power? 1. What's the highest? 2. This is a quadratic equation. What's the power of my variable here? 1. What's the power of my variable here? 1. What's my highest? 1. That is a linear equation. Do you see the difference? Now, do not write this down. Just listen to me. If I had the equation like this, this would not be a quadratic equation, because what's the exponent of my variable? 3. What's the exponent of my variable? 2. What's the exponent of my variable? 1. What's my highest exponent? 3. You do not need to know this. I'm just telling you, it's called a cubic equation, okay? You only have a quadratic equation when your highest exponent of a variable will be a 2. Do you understand that? So you have to learn to recognize your quadratic equations. Now, I want to show you something else. You can copy this down or just watch. You probably just watch and you'll be okay. Now, some students will look at this problem and they would say, oh, this is not a quadratic equation because my highest exponent is a 4. second. Let's go back to that sentence I had you write down, okay? I said the highest exponent of a variable. That means a letter, a variable. So the only thing you're looking at, students, would be the variable, okay? So, and actually by drawing this circle right here, I cannot go back now to that equation I just had, so I forget what I had written. What did I have written, guys? It was something like this, wasn't it? If I don't get this exactly right, don't worry about that, okay? It was something like this, but you get the point. This is a quadratic equation. It is, because you do not, this is not a variable, this is a 15, it's a number. You have to look at your variables. Here's a variable, what's the exponent? 2. Here's a variable, what's the exponent? 1. What's the highest exponent between the 2 and the 1? A 2. So yes, this is a quadratic equation. You've got to understand what a quadratic equation looks like. You look at the variables only, and if the highest exponent is a 2, then you have a quadratic equation. Now let's get into solving some of these, okay? Before I do that, I need to explain something to you. There are different methods that are used to solve quadratic equations. Each method is important for you to learn. You can tell by the heading today, we're going to use the square root method today, okay? So make sure you understand this is only one method out of quite a few methods we're going to learn. So this method is called the square root method. Here are the steps. Please copy these down. I am going to continue on, so you might have to pause the video. Step 1, isolate the variable of the square term. Actually, you know what, guys? I probably should have put another step in here first, and I apologize. That's my fault. So we're going to call this step 1. Always simplify both sides first. That's very poor teaching on my part. Simplify both sides of equation first. That's very important. Simplify both sides of. Not sure if this thing has a dead spot. I'm not sure why it's not working. Simplify both sides of the equation. Step 2, isolate the variable of the square term. And step 3, take the square root of both sides. Don't forget, there should be one word there. Don't forget the positive negative sign. Okay, so there's your steps. I'm going to move on. And as soon as I go like this, it's going to be gone. This top part is, so pause the video. Copy these down. I'm going to move on. Let's try some of these, okay? So here we go. Alright, notice right away I have a quadratic equation because my highest power is a 2. Highest exponent of a variable. So step 1, simplify both sides. Nothing I can do. Step 2, isolate the variable. That's already done. This variable is all by itself. Now you say, Mr. Earhart, there's a 2 with it. Well, I know that, but I mean, I want the variable all by itself, for example. See this problem here? The variable is not by itself. I would have to get rid of the 3 and get rid of the negative 48. Okay? So when I say to isolate the variable, I'm talking about the variable and its exponent. Okay? And look, they're already isolated. We're done. Okay? So step 1, simplify both sides. There's nothing you can do to this side, and there's nothing you can do to this side. Step 2, isolate the square term. The variable is already done. So now lastly it says, look at your steps here. Take the square root of both sides. Alright, so here we go. You're going to learn something new here. I'm going to take the square root of my left side, and I'm going to take the square root of my right side. Okay? Now, when I take the square root of x squared, I just get x. How do you know that, Mr. Earhart? Well, come on, guys, think about it. What's x times x? X squared. Just like 2 times 2 equals what? 4. So the square root of 4 is what? 2. Correct. Well, the square root of x squared is x because x times x is x squared. Now, notice in your steps it says, don't forget the positive negative sign. Anytime you have to put plus minus in front of your answer or positive negative because you have to remember that's part of your answer. Remember, there's possibly two answers, Mr. Earhart. There's no positive negative here, so why do I put it here? Well, two reasons. First of all, you chose, you chose to put the square root in. And secondly, when you're solving an equation, do you not want all of the answers? Sure you do. You want all of them. So you don't want just part of the answers when you solve an equation. You want to get all the answers. So it is your job to put the positive negative sign. So there's your answer. So Mr. Earhart, you're telling me there are two answers to this equation? Yes, there are. The first answer is positive 2. Let's see if that's right. Put a positive 2 in here and square it. And what do you get out? 4. Now, put a negative 2 in for your x. Square it. And what do you get out? 4. So there's your two answers for the equation. Let's try another one. If I go too fast, pause the video. If you feel really confident, go ahead and write the problem down and you can try it on your own, okay? Alright, step 1 is simplify both sides of the equation. Well, there's nothing we can do there. Both sides are simplified, okay? Step 2 is isolate the variable of the squared term. Well, here's my squared term. Here's the variable. It's already isolated, so we're good. Last step. Take the square root of both sides. Don't forget the positive negative sign, okay? So I'm going to take the square root of x squared. And I'm going to take the square root of this side. Now the square root of x squared is x. Now here's where it gets interesting. Because 5 is not a perfect square, I'm going to have to use my calculator now. Let's say the directions on a test or a quiz said, solve the equation and write your answer in radical form. Remember we talked about this a couple minutes ago. So if the directions say to write your answer in radical form, then you would bring this down and your answer would simply be this. Do not put this on the inside, it goes on the outside. So there's your two answers. Positive square root of 5, negative square root of 5. Got it? Piece of cake, no problem. What if the directions said to write your answer in decimal form? Okay, still no problem. You simply take your calculator and you type into your calculator the square root of 5, which I'm doing right now, and we should get 2.236 and so on and so forth. But don't forget your what here? Your positive negative. So there's your answer. So this can be your answer, or this can be your answer depending on what the directions say. Radical form, this would be your answer. Decimal form, this would be your answer. Let's try another one. Please copy this in your notes. Step 1 says to simplify both sides of the equation. Alright, and so let's do that. And actually we can't. We have unlike terms here. You cannot put those together, so we cannot simplify this side. There's a 0 over here, so we cannot simplify that side, okay? So we move on. Next, isolate the variable of the squared term. So, here's the squared term. Here's your variable right here. Let's isolate that, okay? Now, I would not divide by 3. I would first move the 40, and I would save this number for last. Bring the 48 over to make it a positive 48. So now I have 3x squared equals 48. Now to get rid of the 3, we're going to divide both sides by 3. And x squared equals 16. There, we did it. Step 2 is complete. We have isolated the variable of the squared term. Last step, take the square root of both sides. Don't forget your positive negative sign, okay? So, I'm going to take the square root of one side and the square root of the other side. And by the way, you're allowed to do anything to one side of an equation as long as you do the same thing to the other side to keep both sides equal. Okay, that's totally allowed. The square root of x squared is x, and the square root of 16 is 4. Now on quizzes and tests, a lot of students forget to do this and they lose points. Don't forget your positive negative. So there's your two answers, positive, negative 4. Now, do you think that's right? Well, we can always check and see, can't we? 3 parentheses 4 squared minus 48 equals 0. Do your power first. 4 times 4 is 16. So 3 times 16 minus 48 equals 0. And 3 times 16 is 48. So 48 minus 48 equals 0. How about a negative 4? 3 parentheses negative 4 squared minus 48 equals 0. 4 times 4 is 6. Negative 4 times negative 4 is 16. So 3 times 16 minus 48 equals 0. And 3 times 16 is 48. So 48 minus 48 does equal 0. So both answers check, okay? Alright, let's try another one here. Please copy this in notes. You can work at or you can watch me. Okay, students, here we go. Step 1 is to simplify both sides of the equation. We cannot simplify this side. We have unlike terms. And we cannot simplify a 5. There's nothing I can do. Step 2 is isolate the variable of the squared term. Well, here's my squared term. Let's get this x all by itself, okay? So we're going to bring the 10 over and make it a negative 10. So now I'm left with 2x squared equals a negative 5. Okay? Now divide both sides by 2. And I'm going to get x squared equals negative 2.5. Alright? Okay, so step 2 is now completed. We have isolated the variable. Take the square root of both sides now. Don't forget your positive negative sign. So the square root of x squared and the square root of negative 2.5. Now the square root of x squared is x. And hold it. Look at this. What did I teach you earlier in the video? You can never take the square root of a negative number. So x equals what? No solution. So Mr. Earhart, you're telling me there's not one number in the world that would satisfy this equation? That's exactly correct. There is no solution to this equation. Now later on, in Algebra 2, when you get into imaginary numbers, then yes, there will be a solution to this. But it's not real numbers, it's imaginary numbers, okay? There is no real solution to this equation, okay? But all you have to put is no solution. That's the end of the problem. So I'm gonna make one more up because I think we need to practice something. So copy this down, please, in your notes. Let's do one more problem. We'll be finished. There. Now, that is definitely a quadratic equation because if you'll look, the highest power of your variable is a 2, okay? So step 1 is simplify both sides of the equation. We have yet to have solved one equation where we had to use step 1. So I wanted to give you one problem where we had to use step 1, okay? So simplify both sides, okay? Well, this is pretty easy over here. I've got an x term here and an x term here. They're like terms. Positive 3, positive 6 is a positive 9. Bring down your negative 5. You cannot put these together. They are unlike terms. One is an x term and one is a constant term. Okay? You cannot put those together. But we can combine our x terms, and we did that. Now over here, I've got some multiplication. Take your 2 and multiply through the parentheses. 2 times x squared is 2x squared. 2 times negative 5 is negative 10. And then bring down your positive x squared. And look at that, we're still not done, okay? Now we have a 2x squared plus a 1x squared, which gives you a 3x squared negative 10. Alright? Equals 9x negative 5. Alright? Now, step 2. Isolate the variable of the squared term. Here's my squared term. Isolate it. So bring this negative 10 over and make it a positive 10. And now I'm left with 3x squared equals 9x positive 5. Now divide everything by 3 and divide this by 3, you're left with x squared. Divide this by 3, you're left with 3x. If you divide this by 3, that reduces to 3. And divide 5 by 3, and you get this. Now look what happens. When you go to take the square root of both sides, there's nothing you can do. You've got an x inside the radical. Now you're saying, why are you listening to me? Well, boy, this thing's really not working well. Are you seeing now why we have different methods to solving quadratic equations? The square root method would not work on this quadratic equation. You have to use another method called factoring or completing the square or the quadratic formula. Okay? So that's why we're going to learn other methods later on, okay? Alright, so really, that's as far as we're going to go with this problem here because the square root method won't work on this, and we'll talk about this later in other lessons, okay? Guys, I hope this video's been a help to you. If you have any questions at all, please don't hesitate to call or email.